Alright, hello there. Welcome to your pre-lesson week 3.2 on inequalities, graphing, and functions. So we'll get diving straight ahead because we have a lot to cover. So the first thing we're going to cover are inequalities, right? So I'm going to remind from the very beginning, when you have a negative sign in your number, watch out for it, especially when you are dividing or multiplying a number. And you'll see why in a second as we go through all these practice problems. All right. And then another thing to just remember is, when we're graphing the line, when we have this, so we have the less than or greater than sign, we would use a hollow dot. And if we have a less than or equal to or a greater than or equal to sign, we would use a solid dot. All right, so this will be in just a second, you'll see. So let's get started first. In order to find an inequality, so it's similar to a linear equation, we want to isolate the variable that we're trying to find. All right, so if we look here, we have x. We want to isolate x. So how are we going to do that? We want to get rid of 2. So we're going to subtract 2 on both sides of the equation. And from there, we're going to get x is greater than 10, right? And then if they ask us to graph, for this case, we would just graph it on a number line. So let's just quickly draw this out. Bear with me as I write my number line. All right, so let's look. Since our sign is a greater than sign, we're going to use a hollow dot. And since our value is at 10, we're going to draw a hollow dot here. You can also draw a hollow dot right on the line itself, but I'm just going to draw on top just so we can see it, right? So from there, draw a hollow top on top of the 10 and then drag that arrow this way. So we have an arrow that's pointing this way, which means 10 to infinity because there's nothing stopping after 10, right? And so this is how you would draw it in terms of the number line or graph it, graphing your inequality. All right. Now the next example would be this. So same thing, we want to group the like terms so that in the end we would isolate x. So I'm just going to straight away, we're going to add 6, subtract 36n, subtract 36n. After that, we're going to get 28n is greater than or equal to negative 10. To isolate that, divide both sides by 28, and that's going to give us n is greater than negative 5 over 14. Note how, yes, 10 is a negative number, but we're dividing both sides by a positive number, so we would not need to worry about this. We'll actually see in, in a few questions down the line where we do have to consider the sign because we are multiplying or dividing a negative number. All right, so now let's continue with this. Let's draw our number line. Ooh. All right, excuse me. Let's bear with me again as I draw this beautiful straight number line. All right, so I know that negative 5 over 14 is going to be about like less than negative 0.5. So, I mean, slightly more than negative 0.5. So I know my point should be here. And because it's a greater than or equal to sign, I am going to use a solid dot. So as you can see, it's completely blackened from there because the inequality sign, the bigger side, is opening up towards n. That means all my values of n are going to be bigger than this number, which is why I'm going to draw my arrow going this way, because I want all of my values to be bigger, right, because we got the bigger side, than this number. All right, and so that's how you would draw this inequality. Now for the next one. Oh, look, we have our variable smooshed in the middle. No fret. So what you would do in this case is that if you do it to one side, you would need to do it to the other side also at the same time. So in this case, the first thing we are going to do is we're going to get rid of the fraction by multiplying the entire thing with its reciprocal, which is just 3. So then that's going to give us negative 6 is less than 6 minus 2x is less than 12. All right. Now from here, I want to isolate negative 2x, so I'm going to subtract 6 from both sides, from all of these, as you can see. And so now we're going to get negative 12 is less than negative 2x is less than 6. And then, look, now we got to divide everything by a negative sign, right? Because we want to isolate x, so we got to divide everything by negative 2. Now, because we are dividing everything by a negative number, we are going to flip all of the signs. So as you can see, now it's going to be 6 is greater than x is greater than negative 3. See how the signs have switched? Look at that. Oh, that's supposed to be a different color. Whoops. Give me a second. So as you can see, the signs have flipped into the other direction. And this is what happens when you divide or multiply the inequality with a negative number. All right. And so another way that's still correct to write this inequality is negative 3 is less than x is less than 6. Normally we write inequalities from smallest to biggest numbers, just a lot easier to see that way. And so this will be our solution. Now, how you would draw that on a number line is this. So let's look. Negative 4, negative 3, negative 2. We'll just quickly draw this number line. All right, so let's look. Less than negative 3, so we'll draw a hollow dot on top here. And then 6, as you can see, right? And because our value of x is going to be in between these two numbers, so that means we're just going to draw the line like this, and that means our solution is going to be between negative 3 and 6. It can't be bigger than 6. It can't be smaller than negative 3. If you chose any values like here and here, it will not satisfy the inequality. All right. So if you pick any values between negative 3 and 6, not including them, you will get your, it will satisfy the inequality. All right. Now we look here, an OR question. So when we have like these kind of questions, we are just going to separate the two equations first into two parts. So we have on one side, m minus 2 is less than negative 8. M over 8 is greater than 1. Let's solve on this side first. Isolate m by adding 2. We'll get m is less than negative 6. Multiply both, and now second equation, multiply both sides by 8 because that's the reciprocal, and we're going to get m is greater than 8. All right, so that means our solution is going to be m is less than 6 or m is greater than 8. Because it's an OR question, that means they don't need to be overlapping, right? They can be on two separate ends and not touching each other. You'll see in a second what I mean as I draw this number line. All right, let's go. So as you can see, all right, let's look at m is less than negative 6. So we'll draw a hollow dot because it is a less than sign, does not have the equal to sign, right? And it will go this way because the smaller side of the inequality sign is pointing towards m, which means that all the values of m will be smaller than -6, right? That's why we're going to draw the arrow to the left, because then it shows that all the values going this way is going to be smaller than -6. And now for the other one, where where the bigger side of the inequality sign is pointing towards m, which means all of our values of m are going to be bigger than 8, right? So we're going to draw again a hollow dot because it's a greater than sign. And because we want values that are bigger than 8, we're going to draw the arrow to the right. So as you can see, our two inequalities, they don't overlap with each other, right? They're on two separate ends, and that was completely fine with the solution because it's an or question. You can have either this or that. Now the next thing that we're going to look at is an and question. Now with an and question, this is really conditional because the answer will be where the two inequalities overlap with each other. All right, so let's look. Again, we will separate this into two parts. Solve the first one by subtracting 8 on both sides, gives you x is greater than or equal to 1. Multiply both sides by the reciprocal of the fraction, which is then x is less than or equal to 7. And as you can see, 1 is going to be greater than or is going to, 1 is going to be less than or equal to x, which is less than or equal to 7. Can you see that? Right? The other way you could also just write the solution is x is greater than 1 and x is greater than 7. And now how that's going to look like on the number line. Actually, I'm going to draw that a little bit lower. Again, bear with me as I draw this beautiful number line. If you think this video is helpful, hit that subscribe button and like this video. Anyways, all right, back to the thing. So if we look at this part, we want part of our inequality to be where x is going to be greater or equal to 1, right? Because the bigger side of the inequality sign has opened up to x. So because there's an equal sign, we're going to use a solid dot. We want all our values of x to be greater than 1, so we'll draw it going this way. All right. Now for the other one, our value is going to be at 7. So draw the dot above 7. Again, solid dot, right? Because it has an equal sign. And all our values of x are going to be less than 7 because the smaller side of the inequality sign is facing x, as you can see. So that means we want all our values of x here to be smaller or equal to 7. So it will be going to the left, as you can see. Now, because it's an and question, we want the answer where the two lines overlap. So as you can see, the lines overlap here and here, which would then give us, like I said, the answer 1 is less than or equal to x is less than or equal to 7. And that's why this is the answer for an and question. All right. Now, there are some possibilities in some situations where you would have all real numbers are a solution, and this is when you have an or question and the inequalities overlap with each other, right? So for example, let me just write or question, the inequalities overlap each other. Right, so I just quickly draw this, yada 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 yada, and get 0, -1. There we go. All right, so just take any points, right? So this is an or question. Say one inequality goes this way, another inequality goes this way, right? Because an or question includes both, it doesn't matter where they overlap, and if they do overlap, which means like all solutions going this way and all solutions going this way will be included, right? And because these two or inequalities are overlapping each other, that means all of the solutions are going to be, all the numbers, all these real numbers are going to be a solution, which means your solution is going to be noted as R. If you write it as an interval notation, it will be negative infinity to positive infinity. And we'll actually get to in a second on how to write interval notations. All right. So if you have any questions about this, feel free to bring it to the deep dive lesson. All right. Now, there's also the other hand where you don't have a solution. All right. And you don't have a solution when it is an end question and the inequalities don't overlap with each other, right? Because remember, with n questions, you need to have the inequalities overlapping with each other to get that solution, all right? So, and by the time you solve it, you draw the number line, yada, 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 and let's quickly draw this out. Say you get one inequality going this way, another inequality going this way. Because it's an AND solution and you need your answer, right? You need the two inequalities to overlap with each other. But in this case, as you can see, they're not overlapping with each other, right? And because they don't overlap with each other, that means you have no solution. And that is only when this is an AND question, all right? Now, we also got to learn how to graph linear inequalities into variables. Again, a very quick thing. If we use these two signs, we will be using dashed lines. We'll see in a second. And if we use these lines with the equal sign, we'll use solid lines. All right, now if we look, our inequality here is going to be 3x minus 2y is greater than or equal to negative 4. A really simple way to graph your lines is convert it into the linear equation format, y equals mx plus b, right? It just makes it a lot simpler to graph your linear inequalities. You just wouldn't change the inequality sign to an equal sign, right? Because in case you do have to multiply or divide anything with a negative number, it will flip. So we're just going to keep the inequality sign as it is, but we are going to rearrange everything into y equals mx plus b kind of format, all right? So in order to do that, I want y to be by itself. So I'm going to subtract both sides with negative. I'm going to subtract both sides with 3x, and that's going to give me 2y is greater than or equal to negative 3x minus 4. Aha, see why we don't change the inequality sign? Because now we are going to divide everything by negative 2, which when we do that, we are going to see, look at that, the sign gets flipped. All right. And then from here, we would then get y is less than or equal to 3 over 2x plus 2. And then from there, we are going to quickly draw our, graph our inequality. All right. So again, as usual, label your axis, please. Now let's see, because I already know what my y-intercept is, I can just straight away plant this here as 0, 2. And I know after adjusting it according to the rise and run, it's going to go 3 units down, 2 units to the left, because I also do want a positive slope. See how if I connect them all, it's going to be moving upwards, right, uphill. So from here, then we're going to draw a straight line that is not straight. Let's try that again. Woo. There we go. We're going to draw a line passing through the dots. We're going to use a solid line because, as you can see, we have an equal to sign in the inequality. All right. And then from here, this is going to be -2, -1. All right. Now, because it's an inequality, we would also shade the region. I'm going to shade it using this. Okay. Because the smaller side of the inequality sign is pointing towards y, that means we want to shade the region that is moving downwards. So if you look here, this region here, if we were to draw an arrow from the line, it will be pointing upwards, which is not what we want because we got the smaller side of the inequality sign pointing towards y. So that means we want the arrow to be pointing downwards. So if we look on the other side, oh, it's pointing downwards. It's pointing downwards. Look at that. So that means the region that is here, so anything below this line, as you can see, is going to be a solution here. So if you put any points here, you pick any point because it's a solid line, right? Solid lines means you can use a solution. So if you use 0, 2 in your inequality, it will satisfy the inequality. If you use any solution here like 6, 0 and plug that into your solution, into your inequality, it will satisfy it. All right. All right, now let's look at the other question. So again, same thing here. We want to rearrange this into y equals mx plus b because it's just a lot easier to graph it like that. So let's subtract both sides with that and add 3. That's going to give us y is less than -x plus 3. Again, we're just going to quickly graph it. All right. So again, just going to quickly, because we have a lot to cover. We have 0, 3, and like 1, 2. Now, because it is a less than sign, we're going to use dash lines to draw. It won't be solid lines, it'll be dash lines. All right. Again, because the smaller side of the inequality is pointing towards y, that means we want the part of the line that is pointing downwards, the region that's pointing downwards, right? So it'll be going this way. All right. So that means any of the values that are in this region, right, would satisfy the inequality. Now, because it is a less than sign, or as you can see, a dashed line, right, you cannot pick any of the points that are on the line itself. So in this case, you won't be able to use 0, 3 here because it will not satisfy the inequality because it's a dashed line. You cannot include it in here. Understand? So, but if you pick anything else like 0, 0, it will satisfy the inequality. 0, 1, it will satisfy the inequality. But picking 0, 3, 1, 2, it will not satisfy the inequality. All right, so dashed lines do not include the solution that is on the line itself. All right, now some other things to remember that might also be helpful is, let's look, where is it? When y is greater than x, your graph, I'll just quickly shade it for you. So the region where that would be like here. When y is less than x, there we go. No equal sign, so it had to be dash lines. So smaller side pointing to y, it will be at the bottom here. This one, y is bigger than x, bigger side pointing towards y. Again, dash lines, bigger, so we'll be going upwards this way, right? Because arrows are pointing upwards. Draw the arrows for you. There we go. Now, when y is greater than or equal to x, negative x, right? That means now our line is going to have a negative slope because it's pointing upwards. So we want anything that goes here. That means your shaded region will be like around here. And then y is less than negative x. We want the region that's pointing downwards. Oh, shouldn't start there. We want it pointing downwards. So that means we're going to shade this region. All right. If you have any questions about this, bring it to your deep dive lesson. All right, the next thing that we have, absolute value inequalities. So a big thing to remember here is that here are actually some tips and tricks to remember. All right. So if your absolute inequality, so if absolute x is smaller than a, or actually we'll put this as case 1. All right. Let's continue. Or a, right? That means your solution for these two would be negative a less than x less than a, or negative a less than or equal to x less than or equal to a, as you can see. All right, so these would be the solutions for that if your absolute x is less than a, or less than or equal to a. Now for case 2, if we look, absolute x is greater than a, or absolute x is greater than or equal to a, right? That means our solution now would be x is less than negative a, or x is going to be greater than a. Same thing from here, but just the inequality sign would be changed. Oops. No, that's correct. Yep. And then we'll actually see in a second what I mean as we go through some of the practice problems. And now let's move on to case 3. All right, so case 3 is when absolute x is smaller than negative a, or absolute x is smaller than or equal to negative a, right? For both of these cases, it will be a no solution. And here is why. Because with absolute values, your solutions are always going to be positive, right? And because of how this is set up, if you think about it, a positive number is smaller than, is lesser than a negative number. That makes no sense, which is why this is going to be no solution. Now, for the fourth case, right, when absolute x is bigger than negative a, or absolute x is going to be greater than or equal to negative a. Now, these two would mean that all real numbers are a solution, right? Because think about this. Again, all your absolute value solutions are going to be positive, right? So even like smallest you're going to get is 0. And 0 is always going to be bigger than negative a, right? So that's why any number you put in here would give you all real numbers are a solution. All right, and so that's some tips and tricks to remember. Now on to some practice problems. So if you look, absolute x plus 2 is less than 4. If we look at this, this will be case 1, which means we know our solution is going to be in the format of negative a less than x less than a, right? So I can set it up as negative 4 less than x plus 2 less than 4. I want x by itself, so subtract both sides by 2. That will then finally give me negative 6 less than x less than 2. All right. And then we're going to draw that on a line. We'll just quickly draw it. We have negative 6, 2. Our solution, I'm going to draw the pink. There we go. Would be this area here, right? which is going to be -6 less than x less than 2. In terms of interval notation, it will be -6 until 2. All right. Now, the next one that we have, look, absolute x plus 2 is greater than 4, which means we're in case 2. Oh, that's supposed to be black. There we go. Which means our answer is going to be set up as x is smaller than -a, or x is going to be greater than a, right? So that means, again, we can set it up straight away as x plus 2 greater than 4, or x plus 2, now because it's a negative number, we're going to flip the sign, -4. So x plus 2 less than -4. From here, we're going to solve it, and straight away, I will get x is greater than 2 for the first one, and x is smaller than -6, right? So that means my solution would then become x is greater than 2, or x is smaller than -6. If I were to draw that on a number line, it would look like this, hollow dots because no equal sign. It will go this way, and it will go this way. This will be x is less than -6, and this will be x is greater than 2. There we go. And then how we will write it in interval notation is that this is going to be -infinity to 6, and this is going to be 2 to positive infinity. All right. Now for the next one, if you look, our absolute equation is less than -4 straight away because we look at this, right? That means anything that we put in here, so anything, so a positive number is going to be negative. Straight away I can tell that this is going to be no solution, right? Because all positive numbers is going to be less than a negative number. That's not true. So straight away, just looking at this, I know it's going to be no solution. Now, on the other hand, I know that all of my values are going to be positive than a negative number, and I know this is always going to be true. And even if it's small, if I put here -2, -2 plus 2 is 0. 0 is going to be bigger than a -4. That's always going to be true, right? So I know from here, surely, that my solution is going to be R. So all real numbers are a solution. R a solution. All right, and then how we could also write this as an interval notation is -infinity to positive infinity. All right. If you have any questions about all of this, bring it to your deep dive lesson. All right. The next thing that we have is the coordinate grid. So as you can see, quickly just draw this out. So when we have like our coordinate grid, it is really important that we learn how to read properly, because if we don't read it properly, we're going to get the points wrong, and that's going to affect our score, right? So from here, coordinates are read in terms of x, y, and they're written in this format, parentheses x, comma, y. So that means if I were to be given the points 2, 3, I know that they would be, there we go, 2, 3. That means my x value is going to be 2, all the way here, all right? And my y value is going to be 3, so all the way. Where they intersect, as you can see here, will be where my coordinate is. So in this case, 2, 3. All right, and that's how you find coordinates. All right, now definition of a function. So function, you can tell it what it is when the x value does not have two y values. And how you could do that is by using the vertical line test. Quickly write that, vertical line test. So I'm going to draw some examples real quick, and I'll explain to you why some are a function and why some others we consider them not to be a function. There we go. All right, now with the vertical line test. So if I were to draw like a vertical line down here, see how it only cuts at one point? Even if I draw here, see how it only cuts at one point? That means I know that this is what we would consider a function because the x value has only one y value. Same thing from here, draw a line, cuts at only one point. Draw a line, cuts at only one point. So this is a function. Oh, look, cuts at one point. Cuts at one point, cuts at one point. This is a function. Now let's look at this one. Oh, it cuts at 2 points. Oh, look, it cuts at 2 points. Because the x value has two y values, right? Because it cuts at 2 points, that means this is something that we would not consider a function. All right. So that's how you would find out if it's a function or not. You use the vertical line test. If it cuts at 2 places, it's not a function. If it cuts only at 1 place, it is a function. All right. Now, domain and range. And we're almost at the end. All right. So domain and range, very important things to know because these come out really common, really frequently in like math tests. So domain, right? So domain is all possible x values of a function or equation. All right. So what this means is that if the line that you're given, the graph that you're given, doesn't have any limitations, right? So as you'll see down the line, like a radical function, a rational function, exponential function, all those would have like limits to your domains or ranges in a second. All right, so it'll really depend on what the function or equation is. But anyways, back to domain. So domain is all possible x values of a function and equation, and how we would look at that is we would look all the x values from left to right. We always write the domain from left to right. And as we do our practice problems in our deep dive lesson, you'll see what I mean, right? And also both for domain and range, we will write them in interval notation. And we'll actually get to that in a second down here on what interval notation is, right? But anyways, domain is all possible x values. You read it from left to right. Now, range, on the other hand, is all possible y values of a function or equation. All right. And with range, we're actually going to look from bottom to top. So that means we're going to start from down here all the way up here. So we go from whatever here, slowly make our way up. All right. And as we go through our practice problems in the lesson, in the homework, and in your quiz, you'll understand more about this. All right, last thing, and then we're done with today's pre-lesson. All right, so function and arrow notation. So what an arrow notation is this. It's just an arrow, right? You've probably seen this in your inequalities. You'll see it in a second in your homework and lesson and quiz and further on in the chapters, right? This arrow. And what this arrow means is that it means it's approaching something, right? So for example, fx, which is function, is approaching infinity, right? So that's what the arrow here means. Right. So this means that the function approaches infinity. All right, so essentially that's what the arrow means. It means it's approaching something. So it says fx arrow 2, which means the function is approaching towards 2. That's all. All right. Now, a really quick thing is interval notation, because you'll use this really frequently in like your domain, your range, how you write your inequalities sometimes, and a few other stuff. Right, so with interval notations, you always want to start from the smallest to biggest value, right? And what I mean by that is if you look, -3 to -5. This is wrong because -5 is smaller than -3. So the correct way to write this is -5, -3. All right. Now, the other thing is that, like I said, this is normally used in domain and range. The infinity signs, right, which is your negative infinity and positive infinity, always use the parentheses. So that means it's going to be like negative infinity to positive infinity, that kind of stuff. You would never use it with a square bracket. Never. No. Infinity signs, parentheses. Another thing is that if you have more than one interval notation in your answer solution, right, you use union, this big U. It stands for union. All right, and remember, if you have more than one interval notation in answer. For example, like -4, 3, union 5, 12. Because there's two parts of the answer, you use union. Alright, now very important thing also, square brackets if point is included. So that's when you have like your greater than or equal to sign. So you put the equal sign in your things. Or if it's a solid, dot, right? And now we would use parentheses if the point is not included, which is when we use like your greater than or less than signs. You have the hollow dot. That's when you would use the parentheses. All right. All right. I know that was a chunk to take in, but thank you for tuning in. If you have any questions, bring it to your deep dive lesson. Have a good rest of your day. Bye.